So a researcher is conducting a study comparing the effectiveness of two different psychological interventions for reducing anxiety symptoms in patients with generalized anxiety disorder. They randomly assigned 60 participants to either intervention A or intervention B. After 12 weeks, anxiety levels are measured using a validated scale, but a Shapiro-Wilk test reveals that the data for both groups is not normally distributed, or are not normally distributed. Which statistical test is most appropriate to compare the mean anxiety scores between these two independent groups? So if you've watched these videos before, folks, you'll know that an approach I often suggest is to cross out some of the possible answers or options that we know it's not. So what do we know in the question? So we've got two different interventions for anxiety. We've got random assignment. Okay, so we know this is not categorical data. This is ordinal or continuous data. So we know it's not the chi-squared test, which is used in categorical data analysis. We know we've got two groups, so intervention A or intervention B. Sorry, intervention A, intervention B. So it's not the analysis of variance, because this is for three or more groups. So we're looking at means then. So it's either independent samples t-test, paired samples t-test, or the Mann-Whitney U-test. So because the participants, the 60 participants, are randomly assigned to A or B, we've got two distinct groups. Now for paired samples t-tests, we use the same group of participants but measured at different points in time. So we can cross out B. So it's either the independent samples t-test or the Mann-Whitney U-test. Now, the Shapiro-Wilk test reveals that the data for both are not normally distributed. So it's the Mann-Whitney U-test. There we go. So this is a non-parametric test used to compare two independent groups, as we have, when the data is not normally distributed. It assesses whether two independent samples are drawn from the same population or from populations with the same median.